Yes, physical students, let's discuss vector product of two vectors. Well, we already know about scalar product. For example, work done. A scalar product or dot product of two vectors, force and displacement. Somebody might ask, F magnitude of force vector as magnitude of scalar vector into cos theta. Why cos theta? Why not sin theta? Right. Let's say this is the direction of displacement, and same is the direction of force applied. Now, angle between force and displacement is 0, and the work done is maximum. Hence, F is cos theta. Why? Because at theta is equal to 0 degree, cos 0 is base becomes equal to hypotenuse 1. At any angle, let's say this is the body, this is the force. We want the body to move in this direction. The work done will be less than Fs. Any work done, which is at any angle other than 90 degree, would be less than Fs. Hence, Fs cos theta. Scalar product. But then we want to talk about vector product of two vectors. Interesting thing, the vector product of two vectors is also another vector. What's the direction of that? Let's see. Let's assume two vectors, vector A and vector B. We want to find its vector product. We are studying the chapter of rotation. Here, two very important quantities. Number one, moment of force responsible for all rotation, and angular momentum. Both are defined as vector products. Let's get a bit of insight why. Now, you can draw the understanding from this. Let's talk about torque. This is, you might represent this by tau is equal to force and the perpendicular distance. Let's say that is r. I cannot put dot here. I have to replace dot with the cross here. So vector product, also known as cross product. Now y this is equal to f r sin theta. I mean to say theta is the angle between force, applied force, and r vector. What's that? Let's say this is a door. it's hinged here. The door is hinged here. And from the center of hinges, from the center of the hinges pass our axis of rotation about which the door swings open or swings closed. You can rotate it. Right? Now, we know that if I apply force here, perpendicular to this, applying force here, there's a handle here. So what's that? You put your arm like this, and 90 degree to this, you apply the force. Now this is the R vector, along this. So this R and F are supposed to be at 90 degree. You will not find anyone applying force like this. You might say he's stupid. But, he has to apply more force in order to swing this door open or close. And then if the force is along R, it's impossible to give an angular displacement of even 1 degree to the door. It becomes impossible. You cannot have R in line, you cannot have force in line with R. You mean to say you apply force in this direction or outwards. You might end up, you might end up taking out the door, or it will not rotate. So you always want this angle between R and F to be 90 degrees. And then you're very comfortable. Why? Because torque is maximum. So if someone says, is it just the force which is responsible for opening the door? No, the answer is not the force, but the torque. Force is one component, force as well as this R and the angle between them, the third thing. So my tau is maximum. The maximum value of tau would be obviously F into R. So this is when sine theta becomes 1. So sine theta is 1 when theta is equal to what? 90 degrees. Sine theta is 0 and theta is equal to 0. Hence, defining vector product as FR sine theta makes a good choice. If you change the direction of F, let's say here or here or here, you cannot open this. Or what? If other way you can discuss is if this is the force direction of the force, so you can see the component of its perpendicular component is at smaller distance from the hinges. So lesser is this angle, lesser is R. So if F and R are inclined, you cannot open it. You cannot put any moment, you cannot put any torque on this. So this is the reason why, what's the significance of cross? And why is it represented by sine theta? Trigonometric ratio is really helping us. Maths, physics, same. Two sides of one coin. We want to discuss about vector product of two vectors in detail now. Vector product of two vectors. Well, few students knew this, that vector product of two vectors is equal to AB sine theta, where theta is the angle between vector A and vector B. But then there's something more to it, more intriguing. So what's that? Let's see. If you want to define vector product of two vectors, we say vector product of two vectors A and B is another vector C, which is equal to A across B, which is equal to AB sine theta, where theta is the angle between A and B, and A is the magnitude of vector A, B is the magnitude of vector B. Now, interesting thing what we learn is what is the direction of vector C, which is representative of cross product of two vectors. For this, you say this. I draw a screw, and this cut is the place where I fit in the screwdriver. So this is a screw. Right? And then we have axis of screw also. Passing from the center. And then, let's say, we define this vector A, and then, let's say, vector B. Now, here it's important when I want to say product of vector A and vector B. It's not that I can write it like this. No way. Why? The product of vector A and vector B, is basically giving me the direction in which the screw is moving. Yes. So vector C is actually the direction of movement of screw. Now, any student can tell me when I'm twisting the screwdriver, putting in the slit given on the this screw, in which all possible directions the screw can move. Any student?
Clockwise and anti-clockwise.
Yeah, if you talk about angular movement, yes, you're right. Clockwise and anti-clockwise, I can rotate my screwdriver. I'm talking about the direction of movement of screw, the translation motion of screw. So either it goes inside the wood or it comes outside the wood, right? If you, let's say, put clockwise movement, if you apply the force clockwise, it goes inside. This is vector C. But then, if you do it anti-clockwise, it comes out. So we need to understand this, that the direction that C vector is basically the direction in which the screw is having translation motion. It's getting inserted, but it's coming out. What I mean to say is that you could always think of your right hand. So you curl your fingers in the direction either from A to B or from B to A. So the direction of your thumb gives the direction of vector product, which is equal to A cross B. So let's understand it here. So let's say I'm having this vector. Vector A, vector B. Let's say I want to define this. I want to define A cross B. So this is like A to B. So you might say that, sir, I can go from A to B like this also. So what do you really mean? Either it's clockwise or anti-clockwise. So here the answer is given by your NCERT book. It says, take the lesser angle. Take the lesser angle. See, between two vectors, there's always possibility of two angles. One is theta and the other is 360 minus 2 theta. You take the lesser angle and then define A to B. And then the lesser angle is this theta, not this. I reject this. So I reject this. Right. So lesser angle from A to B is theta. And now what I do, now since I'm writing with digital pen, I cannot explain this. Now the students who are listening, what they do, they curl their fingers from A to B and see in which direction your thumb goes. Can you show? From A to B, in which direction your thumb goes? Can you tell me? Students can do it. Curl your fingers from A to B. Curl your fingers in this direction of your right hand. So can you see that your thumb points outside? Thumb points not inside this, your mobile screen, but towards your eyes, towards your face. Can you see that? Curl your fingers from A to B. Curl the fingers inside and see your thumb is protruding outwards towards your face, towards my face I'm teaching you. So this is like right hand thumb rule, which gives explanation for the vector C, which is equal to A cross vector B. Now see students, if you take B to A, so now again you use right hand, don't use left hand. So make sure you're left-handed. Use your right hand and do B to A. So see that there's no way you can do B to A except your thumb going inside. Thumb going inside means going away from you. When you curl your fingers from B to A, your thumb is going away from you. It's not going towards you. Okay. So that is right hand thumb rule. And that is how the vector product of two vectors is taken. Something more. Now, can you answer that A cross B? Okay, let's say A cross B, in this case, is coming towards us. Okay, then it would be equal to what? B cross A. Can you guess? Just negative sign, because the magnitude of both are same, but just a sign reverses, and hence this. So now another thing. Let's talk about scalar product. If you multiply vector A dot vector B, well, this is equal to yes, students, scalar product vector B dot vector A. But then if you talk about a vector product, this is not equal to you can say it's not commutative. But then let's talk about distributive property. So if I have vector A and cross product vector B plus vector C, this be equal to cross product of A and B plus cross product of A and C. That means it's distributive it's distributive, the vector product. But then the scalar product is also distributive. Is equal to A dot B plus A dot C. Make sure you put the arrow, very important. This or this doesn't matter. Okay. This is done. Now comes next. Can you guess, students, what will be the vector product of the vector itself? Can any student guess? So this would be, what will be the magnitude of vector A? A. So magnitude of vector A sine. So what will be the angle between both the vectors? So both the vectors, same angle. Angle is, what's the angle, Ishma, between these two vectors? Good. Sine 0. So that will be equal to sine 0 is, it's because of perpendicular, it comes down. So perpendicular becomes 0. Sine 0 is 0. So remember that vector product of a vector with itself is a null vector. Is a null vector. Okay, same direction, but then its magnitude is 0. Okay, guys, from this, we can equip yourself towards doing numericals, which we'll do in the next class. But now we'll just equip yourself. So what is the unit vector towards x-axis? Unit vector towards x-axis?
R cap.
Unit vector towards y-axis?
J cap.
Vector towards z-axis?
K cap.
All right. Now I want to define what will be I cap cross j cap. Can any student tell me? I'm taking it in cyclic way. First, I'm taking the things in a cyclic way. Well, you remember that this is the origin. We don't draw the circle, in this direction. We always take the angle anti-clockwise. Hope you remember. Theta is always taken anti-clockwise, and then we say the theta is positive. If it is taken clockwise in this direction, we say it's negative. Remember that. So what would be I cap cross j cap?
IJ sine 90.
Okay. IJ sine 90. Fine. I cross j cap. I cap cross j cap would be a vector. I and j are lying in, you can say, xy plane. Right? If these two vectors, A and B, whose vector product we want to find out, if they are lying in a plane, so the vector product would be perpendicular to this plane. It would be perpendicular to this plane. Always perpendicular. Perpendicular to this plane. So which vector is perpendicular to the plane of xy? I vector I cap and j cap both are in xy plane. And which axis is perpendicular to x and y?
Z axis.
Correct. So it's given as k cap I cap into j cap is k cap. See, this is unit vector, unit vector. So, and if you really look at what you said, Ishma, will end up here only. This is equal to what? What is the magnitude of I? 1 multiplied by 1. See, I'm not using dot product. I'm just writing this dot to just say it's getting 1 is getting multiplied by 1, getting multiplied by sine of angle between I and j. So what is the angle between I and j? 90 degree. So this is equal to 1. But what is the direction of this 1? 1 vector. What is the direction of this 1? Come on, guys. What
Towards Z axis.
towards z axis and a vector having, it's beautiful, a vector having identity magnitude, that's magnitude 1, and towards z axis is known as
K cap.
k vector, and hence result. Similarly, so interesting. Again, I'm taking things in cyclic order. You can always apply your right hand also from x to y. You please curl your fingers from x to y. Now, you might always say that the angle between I to j can be gone like this also. No, we'll never go like this. We'll go with lesser angle. Lesser angle is 90. So when you go I to j, towards which direction your thumb is protruding? It towards your chest, towards your body, right? That is, if I'm having laptop in front of me, so from the screen of laptop towards my face, that's the direction of z-axis, right? Hence, well, this is also a vector. You remember that. This product is also a vector. It's not scalar. It has a direction. Okay. So, guys, similarly, you can say j vector, j cap cross k cap would be equal to, now I did not explain to you, this is y z plane. So which axis is perpendicular to yz plane? It's x-axis. And the unit vector towards x-axis is? Yes, students, I cap. Similarly, I can say k cap into I cap would be equal to
J cap.
beautiful. That is the unit vector along y-axis.
Y axis.
That's really great. That's really beautiful. Great. Now, from this, we have interesting results also. What would be I cap cross I cap?
0.
Beautiful. Similarly, j cap cross j cap would be equal to k cap cross k cap would be equal to null vector. You should not say 0, you should say null vector, because we have understood that the vector product of two vectors is not scalar, it's a vector. So guys, from this, can you also tell me what would be j vector into I vector? So now you're curling your right hand, curling your fingers from y to x. Then where is your thumb going? Thumb is thumb is pointing towards the screen of your mobile or your laptop. It's going inside the laptop. It's not coming outside. So it would be minus I cap. Similarly, can you tell other results? Now you go non-cyclic way. First we went cyclic way. The answer was positive vector. But now we're going uncyclic, non-cyclic. The answer will be negative. Like you can go uncyclic, non-cyclic, I cap, and to cross j cap, k cap would be equal to, yes, I cap cross k cap. We're going negative.
Minus j cap.
Beautiful. Minus j cap. Similarly, what else is left? I is gone, j is gone. Now I'm going to find k. Okay, so you can say j cap cross I cap. Had it been I cap cross j cap, oh, we have positive vector k. Because it's going, towards us, but now it's going away from us. So it is what? Minus k cap, right? So we have interesting results like, okay, we have learned about vector product. Okay, fine. So learned something. All right. So you should be able to do the numericals also. So we have a numerical in your NCERT book, simple numerical, but you have a numerical 3 I cap minus 4 j cap plus 5 k cap. This is representation of one vector. It's inclined to all the axes, x, y, z axis. I'm talking about scalar product, dot product. Minus 2i plus j cap minus 3 k cap, right? So what it will be equal to? Yes, anyone? Yes, can you guess? So first we multiply this 3 I cap dot minus 2 I cap. Am I right? Am I right? So we go on the right side of work. So we know that what is I cap squared? Well, this is I cap dot I cap. Well, this is equal to, see, this is not vector product. This is scalar product. So this would be what? I square, what? I square cos, what? What is the angle between I and I? Same vector has angle of 0. Cos 0 is how much, Ishma?
1.
Cos 0 is 1. Oh, that's good. So this is equal to 1 without any direction, right? So this will be equal to
Minus 6.
beautiful. That's good. Now the trick is, it's only one mark sum. When I do plus 3 I cap dot minus 2, minus 2 I cap already done, minus j cap. So the angle will become between these two vectors I cap and j cap would be between I cap and j cap. What is the angle? It's 90 degree. So now it's dot product, and dot product is distributive. So I can always have dot product of this with this, this with this, this with this, like I do normal digits. But then when I'll have 90 degrees, so cos 90 would be 0. So this will become 0. When I multiply this with this, 0. The only, only components which will contribute to my answer would be when I multiply I with I, j with j, k with k. Otherwise, whenever I'm multiplying j with I or j with k, answer would be 0. Or k with I or k with j, answer would be 0. So this will be minus 6. Then come on, plus.
Plus 4 minus 15.
Oh, that's beautiful. So that is equal to. It's equal to. Come on, tell me. 15 plus 6 is
Minus 17.
what? How much? Tell me.
Minus 17.
Oh, one second. See, students, you've done a mistake. You've done a mistake. Here it will be minus 4 into minus 1. So this will be what? One second. Let me see the question.
It will be plus 4 only.
I'm sorry. Oh, yeah, it's okay. It's okay. Fine. So this will be how much? Minus 17. Now, this is correct. It's correct. 15 plus 6 minus 21 plus 4 minus. I thought this is plus here. Okay, fine. So now the homework I give you is the same two vectors. Find its vector product. So guys, hope you like this. Don't forget if you really like this, enjoyed this, don't forget to subscribe our channel, Learn CBSE, and refer to your friends. Press the bell icon. Wish you all the best. Wish you great career.